Hi guys, I thought I'd show you a little bit about what I've been doing lately. This is a Philco 4150. It's a radio I had showed you, just the chassis, and I think I showed you a whole radio a while back on another previous video, and showed you this chassis real quickly in a past video. Uh, Basically, old rubber coated wiring that had to be removed. Most of it was in this condition, so these kind of really go, that rubber just deteriorates and goes bad pretty quickly. So for the most part, most of the wire has been removed as well as virtually every resistor, and of course the caps, all the paper caps anyway, and electrolytics. Rebuilt the cans. I was going to restuff the paper caps, but a few of them had already been replaced, so they're not Philco branded anymore. I think there was a couple air boxes and I don't remember what other brands, but there was a few of them that had been replaced. So, and I didn't really have anything that would even come close. I'm not as concerned about part numbers as if the tube, that I replace it with would be not only say Philco on it, but also say that, if it's a .01, it's a .01 or whatever. So the ones that I would need to replace in it, that someone had replaced in the past, what I had wouldn't match the actual sizes. So anyway, the wonderful thing about it was the speaker wire is in excellent condition. The radio actually is in pretty good shape. There was, I had showed this before, there was one small little rust spot. Otherwise the chassis was in beautiful shape. Rewired both IFs, primarily, they're all rubber coated, and in both of them they had at least one or two wires that were already in deterioration and breaking up, and instead of just replacing those, I usually just go ahead and replace all the rubber. It's the best way to do it, because eventually the other that you don't replace will deteriorate further and become hard and brittle. But most of the actual wiring, other than once the switch assembly's in here, and I've got the oscillator coil yet to go in, most of the other wiring has been already done and patched in. I got the power supply hooked up. I've got all the various feeds. The brown wire is the filaments, green is for grid, orange, green, red, B+. So I'm actually to the point of just starting to put in a lot of the individual components, capacitors and resistors, as we go along. The only two that were basically good was these two guys here. This makes up the divider circuit coming off the center tap of the secondary on the transformer, and it's the divider network for your bias voltages. The radio is has 241s and push pull for audio output right here, and they're supplied off the divider network here, right here, coming up, going to the grids of approximately -14 volts, and then several of the other tubes are supplied off the tap here after 15 ohms. and it supplies -3 volts to the rest of the tubes in the radio. So anyway, we're just going to kind of work on this today, and I'll be clicking the video on and off as I go along. I'll do a little bit on video and kind of, you know, work those details out, and so that you can kind of get an idea of what I'm doing here. But I'll just kind of show you as I go through, as I progress through the different things. Now, the interesting thing about this radio too was, even though the rubber coating wiring was pretty badly deteriorated, the 4-corner rubber pieces that go on the 4 corners that allow the radio to float and not vibrate were in excellent condition, as well as my grommets here and here. This is for the switch assembly for the push button switches. They're in excellent condition, as well as the tuning capacitor fits on here. There's a bracket sits up. I still got a little cleaning I want to do on it, but they're in excellent condition. So it's a rather interesting thing about, you know, the rubber wire kind of deteriorated, but yet the rest of the rubber parts are in good shape. Now, the only thing that was going on with these, which is not a big problem, the radio was fastened in solid, which it shouldn't have been, so probably whoever worked on it last, they had replaced some of the caps in here. When they put the chassis back in, they clamped down the bolts, and those bolts are supposed to float, not be tightened down. It should be sitting on the rubber corners, and what it ended up doing was depressing. It didn't deteriorate, but it depressed into these corners, metal corners, into the rubber, which is permanently depressed now. So what I'm going to do is I'm going to put something in here as a shim, something plastic or something, that'll kind of hold it back up, and then it'll set up like it should. And, you know, case in point, if you work on a radio that has any type of rubber mount that floats it off out on the cabinet, when you put your chassis bolts back in, don't tighten down. They, you know, don't lock them tight. Just screw them in there and just basically finger tight. Let her float like she's supposed to, because otherwise you're defeating the purpose of your rubber mounts, and then you eventually, even brand new rubber, doesn't make any difference, within a short period of time will take up that set. It will be squished down and stay squished down. So just as a little side note there. And so anyway, let's I kind of wanted to show you how I measure out wire. So anyway, this is comes off the switch here, power switch, and comes back over to this bait-like block, which I've replaced the capacitors in. This is your line capacitor, so there's 2 safety caps in there. There'll be the .01s. They are these 2 right here. So those have been replaced. So your plug hooks on each side of those. So you get a wire that goes from the switch to that block, and then another wire from the transformer comes up to the switch, which happens to be this wire here. So we're going to measure this out, and we'll probably just go right in here and do about that much. Run that right in there for right now. Follow out basically the length of the other wire, and it goes right here, so that's my length. Now we just put it in here, wrap it around. Clamp her down good. Let's see if I can kind of come in a little closer there. Alright. Now these wires were twisted originally by the factory, so I'm going to go ahead and do that. Since there's you got your 60 cycle coming on this, flowing through these wires, are going right past the audio transformer here. I'll leave some quiet. Probably do one more wrap. And we'll solder this in with our iron. Enough. We'll feed our other wire in, and we'll clamp it down. Don't ever trust solder to be something that's going to hold things for you. Certain parts of radios, depending on what they are, certain power resistors, things like this, can get close to at least half the temperature of solder's melting point. And anybody that's worked with metal, like bending metal like steel, if you want to bend it real easy, you just heat it up. You get it red, which is getting up there about half to 3/4 of its point of melting. Generally about half is when it's turning red. It bends real easy. Well, if you get temperatures, solder melts at a very low temperature. So if you get temperatures up, it's easily a hit, 200 degrees or so, 250 degrees is getting real close to its half point. And at that point, it's lost half of its structural strength, its tensile strength, and all of its different metal strengths. So if you just rely on solder to be your main holding power, you could be asking for trouble. Now, you can get by with a lot of places in a radio, but again, if you got like a 5-watt resistor or higher, those can easily hit temperatures near the melting point of solder pretty darn easily. They can get up around 400 degrees, so 350 to 400 in that general area, and that's Fahrenheit for my international viewers. But they can get pretty darn warm, especially like a 10-watt or even higher. So, and depending on where it's at, depending on how much heat builds up and everything else, you're heating that up, and it's not really the best idea. They make the terminal strips and the other connections in these tube sockets and everything designed to wrap the wires around and lock them down mechanically and then solder them. They did that for a reason, and so it's something you don't want to just don't second guess that part. Now we'll bring this wire in here. And wrap them around. Now I won't solder that until I get my cord for this hooked up, and I'm not going to mess with hooking the cord up. It's bad enough I got to deal with the speaker cord and the dial light cord and that stuff, but having a 5-6 foot length of power cord on there, just moving the chassis around and doing things like that can be a pain, to say the least. Well, I'm going to continue to work on this, and as I get further along, I'll shoot some more video. Can't really think of anything else to tell you about it. Here pretty soon on one of the segments, I will show you I got to get them dug out, the push button switches and stuff. There's a few things I want to check on them. There's a couple ceramic caps on them that I want to check and make sure they're all right and they're not leaky. They're notorious in these radios for doing that. So when I get a little further along, I'll get back to you. Alright, we're back on. Thanks for video. The magic of video editing and clips. It didn't seem like I was gone very long, but I've been away for a little bit. A little longer than I anticipated. Had a few things errands I had to do. Well, we'll continue on with this. I have made some progress. Got some wires hooked up here. These will be going up to the switch. I still got to do a little cleaning on it. I did some testing, but this is the switch. We have a set of coils and trimmer caps, and this is what sets your presets on here. I did test this cap and this one here, which is the same thing. They're the same exact caps, both 370 picofarads, and then this 220 here. They all tested good. No leakage, right on the money pretty much on their capacitance. So I got some wires to hook up. Some of these will hook up onto this, and once it's in place, thought we would continue on here and start work on some other parts of this radio. A few things to hook up and then solder in place. So we'll just continue on. This here is part of the feedback coming from the volume. There's the volume control here. There's a tap on it that is, I believe, it doesn't say exactly. I don't know if it's right at center or a little to one end. But what it does is it actually provides a little bit of feedback from the volume control into the tone, which eventually gets up to the plates of the plate of the preamp of the radio. First audio. And kind of gives a little bit of negative feedback to keep from distortions reduced down. I have discussed this, I think, a while back on one previous video, talking about what hooks up where, what all the different capacitors do, decoupling capacitors and things of this nature. So what we're going to do here is we just got a capacitor to hook up to this. I think I'll hook it over this way. I think I'll put to keep it out of here, I think we'll put a little bit of stuff on it. Spaghetti. about the right length, so we're about right in there. Just to kind of insulate it. Cut that lead off. And we'll just go ahead and solder it up. There. That one can be soldered. There. Now I've got to run a lead over to here too. Short little piece of wire. Probably attach the ground to that tone control. Center wiper is just hooked to ground, and then as you rotate it, it goes through either one of these two capacitance along with the feedback, and that's how you get your tone. It's just basically a time constant between the resistance that's in here and the two capacitors. And we just cut it, strip it, and connect it. It's probably not the most fascinating part of the video. I'm not really teaching anything. I did want to say while I was here, I am working on, not sure exactly what day, but sometime this weekend or early first of next week, getting up another video on, or two, on the transformers. And I've been thinking about them a little bit, and I think what I'm going to do, we're going to simplify it just a little bit. You guys are probably not super fantastically interested in a full design of transformers. You're more interested just more of information that pertains to working on radios. If you have to replace a transformer, you know, what you're looking for, how to figure out which one to get, and so forth in this nature. We'll continue to talk about some of the losses that's in them and some of the different metals that are used for the cores and some of those nature things. But other than that, to really do them real justice gets into some very heavy math, and so I don't really think anytime soon you're going to be really worrying about doing a serious designing and building your own transformers, at least not standard transformers. Coils maybe. Coils are a little more simpler, although they do have some of the same losses and stuff, but you can get by with, say, if you need to wind an oscillator coil, you can get by with some basic information about, you know, number of turns and things of this nature. So anyway, like I said, I'll be working on getting that up. I'm trying to get a couple more. I want to get into audio transformers. That's probably the one that probably has the biggest questions. We're going to talk a little bit about impedance and a few things of this nature, and we're going to talk about how to, if you're designing an audio amplifier and you're going to have a transformer in there, what you're looking for as far as number of turns and this type of nature and how it's figured. We'll talk about the difference between the various different transformers, audio transformers, power transformers. Why can't I use a power transformer for audio transformer? But anyway, that's on another video, and I will be getting to that fairly soon, and this week anyway, this coming week. So we will continue on with this project. So as I look through this, I'm following the schematic, making sure I'm getting everything hooked up where it should be. Anyway, I don't talk much when I'm basically concentrate on what I'm doing, so it kind of does make for a poor video. This is a cap that hooks from the filtering section of the detector, which is down in the IF can, and comes up. And some radios have these, some don't. But it's just an extra cap that is connected in there. You'll be familiar with, on most schematics, of this cap here, which goes to the center wiper and then runs over the grid. Now this one is the one I'm hooking up right now. This is your filter I've talked about before on the detector, the pi filter, and this cap fits in right here. And it's just adding just a little bit of, well, smoothing out the high tops and just kind of mellowing, I guess you would say, the sound is why they've got it in there. So, but that's what that cap's doing and why it's there and what I was putting in. And next thing I'll be putting in is this 470K. Hope you can see that. This here is basically a load, and what this does, this is where the ABC voltage actually is developed, right on here, and because it's to ground. And after you get filter, now some radios will only use the volume control as it. That's why the size of volume control is very important, and it still is, because it's basically somewhat in parallel. Even with the cap in there, you can kind of consider it that way, although the cap kind of separates a little bit. But this here will produce our negative voltage on here, which feeds back up through the line. This tube is not in this radio here. We're just using a 7C6 as a standard dual diode triode. So this just actually feeds up and hooks right to here. The two diodes are connected through a 2.2 meg resistor. So, yeah, it's right there. It is. I've got to connect that resistor in. We'll put him. He goes to ground. These leads are pretty short on these resistors. Okay, that's in there. Now I got hook in another cap. Now the cap I'll be hooking in next is this 0.05. This is part of the AVC circuit. It's this guy right here. It works in conjunction with this 2.2 meg. That is the time constant of those two together, which is pretty much a standard, is 2.2 megs and 0.05. And I've discussed this before, it allows the AVC to do its job, but slows it down enough so that while you're listening to whatever you're listening to can have some high pitches and a little loudness and back down peaks and stuff without causing the AVC to try to kick in and stuff. So these two make up a time constant. Well, I'm putting this cap in now. And he goes to ground, which is right here. And let's see, I want to bring him down underneath, make it a little neater, like that. Up, which is a little bit tight right there. The excess. Now double check. That looks like everything is in place. So now we can solder it. But a lot of wires on here. Takes a little while to heat up. There we go. Okay. Now I've got a few other things yet to do. I'll probably go ahead and finish the radio off camera, and then I'll come back and either today or tomorrow. I don't know if this will, depending on how much time has expired, this is probably a long enough video between this and the first clip. I'll probably go ahead and put this up and call it, I guess, part 1. And then on part 2, I'll have the radio pretty much done underneath the chassis and everything. I'll show you where I'm at and all the other connections and parts I put in on it. So until the next video, thanks for watching, and thanks for your comments, and thanks to my new subscribers. We'll see you on the next video. Have a good evening, guys.